Welcome. In this session, we are going to build a Python-powered car simulator complete with a GPS system, a trip computer, and a smooth engine startup sequence. And while we are cruising through this digital highway, we are also going to master one of the most important and confusing concepts in Python, if name equals main. So, buckle up, adjust your mirrors, and let's take this code for a spin. Let's open up our first file, car-dashboard.py. We will have 5 steps for this file: the data for dictionary, function without argument, we will use that to start the engine, another type of function with argument and return, we will use it for trip computer, then main program for the driving logic and the ignition key. Instead of writing top to bottom, we will work on several parts simultaneously from the very beginning. I found this style always helps to write big code with better understanding and less error. Before we start the engine, every car needs a navigation system. Here, our journey begins with the GPS favorites. We need to store the destination our car knows. In Python, we have different types of containers. This time, we will use dictionary. Now, why a dictionary, not a list? A list is like a grocery receipt. You have to read line by line to find what you need. Item 1, item 2, item 3. And a dictionary is like a vending machine. You don't look at every snack. You just type the code or the key, say A1, and you instantly get the specific snack. That is the value. In the same way, you don't want to type in GPS coordinator or distance every time you drive. In Python, you give a key for the location name and you get a value. Here in our case, that value is the distance. Now come to section 4 and loop through the dictionary keys. Here, place is the key and we are using that key to call the value from the dictionary. To make it look nice, let's add an emoji. Here, we created a dictionary in section 1. And look through the dictionary in section 4. Run the file, we can see the keys and the values printed here. Now that our GPS is loaded, it's time to bring the car to life. To start the engine, we normally need to inject the fuel, spark the plugs, and then the engine starts. Run it and we see that engine is started. If we want to start the engine again, we need to use this block of code again. So if we write that code manually every time, it gets messy. In real life, do we inject fuel or spark the plug every time? No, we just want to press one button and have the car do the rest. In Python, we use def to define customs command into a function. Let's create a function called start engine. Now look at this red squiggly line. If you hover the mouse over it, it gives you a hint. Indent expected. You must indent the code block, and in Python, indentation is a mandatory syntax used to define code blocks inside a function. Now if you run the file, you won't see the start sequence. Why? Because we defined the button, but we didn't press it yet. We haven't called the function. Come back to section 4 and call start engine right before the GPS block. Run it to see the function in action. There, the engine is started. If we call start engine twice, we see the sequence runs twice. This is the power of functions. We write the startup instruction once and now Python handles the complex sequence for us whenever we call it. Remember to delete this second call before we move on. So, now that engine is humming, let's check the trip computer. Let's create this calculate fuel function. We will start by making it return none. Now let's make the function smarter. It should take an argument inside the parentheses. Here the argument is miles. Let's assume the MPG, miles per gallon, of this car is 25. So fuel needed will be miles divided by 25. Replace this none with the variable fuel needed. So this calculate fuel function now takes in miles as an argument, processes it and returns how many gallons we need. Let's test this. Come to section 4 again. Let's hard code a distance variable as 100. We'll change it later. Call the function and put the distance inside it as the argument. If you run it, you won't see anything in the console. Why? Because we didn't assign the return value to anything yet. So let's assign it to a variable called gallons and print it out. Run it. Success. Trip used 4 gallons of gas. How it worked? This distance value 100 was plugged in the calculate fuel function as miles. Then 100 divided by 25 equals 4, which was assigned as fuel needed inside the function and return. After return, we assigned that value as gallons and printed it. Confused? Okay. To understand better and show you how it works, let's debug the program. Put a red dot here in the distance variable statement. When we debug it, we see the dictionary value in the threads and variable window. Now step over to the next line. We see the distance variable is 100. Now click step into my code to go inside the function. This takes you to the line where we calculate fuel needed. Look carefully at line 20, where we define the function. And here it is showing miles equal 100. The value was passed successfully. Now step into, it takes you to the return statement. And in the thread and variables, we see that fuel needed equals 4. Click step into again, it brings back us to the line 33 again, where we call the calculate fuel. We don't see the gallons variable yet. Now click step over. Here you go. The gallons variable value is 4 now. Step over again and we see the printed output in the console. Now I think you got the picture. What is the workflow of a function? Close the debugging for now. Look at the code what we did so far. We created a dictionary, then used a function without argument and return to start the engine. Then we used a smarter function to calculate fuel with argument and return option, and then tested it, debugged it for better understanding. Now we have a GPS, an engine and a fuel calculator. Let's finish the driving logic in section 4. Remember, we said we would change that hard-coded distance variable. Let's ask the user for a destination first. Then we search for this destination in our GPS favorites dictionary. We replace the hard-coded 100 with the value from the dictionary. Run it. Put the destination as home. We see the trip used 0.2 gallons. Run it again with work. We get 0.6 gallons. Now let's properly structure this. Indent the gallons logic and put it inside if block. And add an else block just in case the user types a place we don't know. Run it. If we type shop, it shows error, destination not found. Perfect. Finally, move all the logic inside a new function called drive car and call that function at the bottom in section 5. Test it. Try gym. It is working fine. Now the line that confuses almost every beginner, if name equals main. Let's break it down with a simple analogy. Imagine your Python file is just a car. Then your functions are the engine of that car, the data is the fuel for that car, and your logic is the steering wheel. But the car does not start until you turn the ignition key. And here this if name equals main is the ignition key. It tells Python only start the engine if this file is being run directly. This prevents the script from auto-starting if someone imports your file into another program. So what happens if another file imports this one? Does the engine still start? Let's find out. Now let's open our second file, mechanic.py. In this file, the mechanic imports our car dashboard. If we run it, we see nothing in the console. That means drive car function was not executed. Why? Because it is in the if name equals main logic inside the car dashboard.py. Now the mechanic is here, he wants to start the engine manually. He can call car dashboard.start engine, run it, and you see the engine start. But usually a mechanic just wants to test a tool. He doesn't want to start the whole car engine. So let's comment out this engine start. Set miles to test equals 100 and call the calculate fuel function directly. Run it, and here is our diagnostic report. That's the magic of name equals main. It prevents the car from starting automatically when imported, but still lets us use the tools inside. If we didn't have that line, the entire driving logic would have executed immediately upon import, which is unintended behavior for a module. And that's your complete Python car simulator with a real-world demonstration of how the main block controls your program. You didn't just write your code today. You build a vehicle, a mechanics toolkit, and a professional-grade Python entry point system. If you enjoy this ride, hit like, subscribe, and I will see you in the next tutorial. Thank you. Happy coding.